Now is the time to present the factorial ANOVA. In this case, a 2x2 factorial ANOVA. And we're going to use the second version of the linear model that we used in the one-way ANOVA. So we've got, as usual, the first part of the model is the same, but how to calculate gamma changes. So we've got the first component of the model is beta0, which is the mean total. So it's the mean of the whole sample. Now let's take an example that we've got variable x and variable z. So we have in x two possibilities, a and b, and in z we've got two possibilities, p and q. So let's consider one study I conducted recently. I tried to generate a visual aid that helps people understand probabilities. So this study presented participants with a problem that required the use of conditional probabilities to be solved, and the dependent variable was the performance. How many correct answers do they have? And the variable x in this case would be the visual aid that was presented to the participants. A is the traditional Venn diagram, and B is a grid that I created to improve performance. And variable z is how many of these visual aids were presented in each problem. So in the case of P, it was presented 3 grids or 3 Venn diagrams, and in the case of Q it was presented only 1. Okay, so these are the two variables with 2 possible values in each variable. So it's a 2x2 ANOVA, and there are four conditions, and we've got one group per condition. So then we've got 4 options. This is the AP, which is traditional Venn diagram with 3 instances. AQ, which is traditional Venn diagram but with only 1 instance. BP, which is the new grid with 3 presentations of the grid, and BQ, the new grid with only 1 presentation. So how do we continue with the model? We've got beta1 times XA, and XA is another dummy variable that we create for this model. I'm going to show you soon. Then we got B2 times XB. Now in this case we've got a symmetrical constraint here. So the node says that B2 equals beta1 times -1. So that means that if beta2 is 0.2, then beta1 is -0.2. And the same with beta3 and beta4. Beta4 equals beta3 times -1. So that means that if beta3 is 0.72, then beta4 is negative 0.72. So it's symmetrical. And then we've got beta5, that's XZ, which is the interaction. So I'm not going to explain the factorial ANOVA because you've seen this before. Now, I'm going to talk about the dummy variables XA, XB, ZP, ZQ, and XZ. So, for XA, here, that dummy variable will be 1 for groups in which A is true. Then we have 1. So AP, we've got 1. And AQ, we've got 1. So these are the groups that went through the Venn diagram. And the groups that went through the grid, in this case, will have 0 in this XA variable. Dummy variable XB will have 1 when the B is true. So for the two groups in which there was a grid, then they will have 1. And the two groups where they used the Venn diagram, they will have 0. So that's regarding the variable X. Now regarding variable Z, we have ZP as the dummy variable, and we will have 1 when P is true. So this is the groups that saw 3 visual aids, and 0 for the groups that saw only 1 visual aid. And the opposite is true for ZQ. We have 1 for the groups that saw only 1 visual aid, and 0 for the ones that saw 3 visual aids. And finally, the interaction. So the way we operationalize the interaction in this case is to give 1 for AP, minus 1 for AQ, minus 1 for BP, and 1 for BQ. I'm not going to explain this in detail. Let's just show the model. Okay, so the idea is the following. You've got a for the variable XA, beta 1 will be the difference between the total mean and the mean for the two groups that went through Venn diagram, and that mean is here. So it's more or less a mean there. So beta 1 is the distance between beta 0 and the mean of A. That's beta 1. And beta 2 is the same, but the distance between the mean total and the mean of the two B groups. That is more or less here. And the distance is exactly the same. So one is positive, the other is negative. So that is beta 2, and then we'll multiply by XB. And then beta 3 and beta 4 is the same, but regarding variable Z. So ZP will be the distance between the mean total and the mean for the P groups. So we've got P, to change the color. The mean of P, of the P groups, is around here, and the mean for the Q groups is around here, quite close to the mean. And it should be the same distance, so P is positive and Q is. So beta 3 is positive and beta 4 is negative. So basically when you calculate the gamma for each of the groups, for the groups that in which the condition A is true, that is the groups of the Venn diagram, then I have to do beta 1 times 1. And for the groups in which the grid is true, so they went through the grid, then we do beta 2 times 1. And for the groups that did 3, I saw 3, then we do beta 3 times 1. and for the groups that so one of the visual aids, and we do beta 4 times 1. Finally, the interaction will be beta 5, and beta 5 here is represented by these red little arrows, and basically it's the same length in all the cases. Those arrows are the same length, these, and basically it means that in the two groups A and B, the effect of P and effect of Q are different. So in the case of A, there is from the mean of A, for the P group there is a decrease, and for the Q group there is an increase. The opposite is true in the B groups. The B groups, the group that did the P, which is 3 instances, the performance was higher, and the group that only saw 1 grid, then the performance was a bit lower. And the length of these arrows is the same, so the distance is the same, and it is the opposite. So the direction. So if there is a decrease in P here, there is an increase in P in B. If there is an increase in Q here, there is a decrease in Q over there. And that's the way we operationalize the interaction between the two variables. Okay, so this is the model for 2x2 ANOVA using version 2, which uses the mean total as a parameter and not using one group as a reference group.